right, section 5.2, day 2, properties of rational exponents and radicals. So if a denominator has a sum or difference involving square roots, multiply the numerator and denominator by the conjugate of the denominator. So we did do these earlier with the conjugate. So remember, on this one here, I'm going to write it as 1 over the square root of 7 minus 2. And remember, the conjugate of that would be the square root of 7 plus 2. Because remember, what it's going to do is going to get rid of the radical on the bottom because it's going to give us a difference of squares. So on the top here, we know that we're going to have the square root of 7 plus 2. On the bottom, I just told you a difference of squares. So we're going to get the square root of 7 squared minus 2 squared. The top is now going to be the square root of 7 plus 2. The bottom, remember, the square root squared is just the number underneath the radical. So we'll have 7 for the first one, and the second one, 2 squared is 4. So we're going to have 7 minus 4. So our final answer is going to be the square root of 7 plus 2 over 3. Okay. To add or subtract like radicals, use the distributive property. So remember, the distributive property is A times B plus C is equal to A times B plus A times C. Now remember, it goes both ways. So if we have something in common here, we can pull it out. We can pull it out on the left-hand side or the right-hand side and then simplify. So on the first one here, we have the 6th root of 17 plus 9 times the 6th root of 17. Again, I want you to think, if I don't have a coefficient, that's the variable in front of something, if I don't have one there, I'm going to put one, because we know that's 1 times the 6th root of 17. So if that's the case, then I can pull out the 6th root of 17, and what I'm left with is 1 plus 9. And again, that'll be the 6th root of 17, and 1 plus 9 is 10. So our answer will be 10 times the 6th root of 17. I'm going to do the same thing on the other ones. So again, I have a 7 and raised to the 1/3 power. So I'm going to take out the 5 plus 6. And then I have 7 raised to the 1/3 power. And 5 plus 6 is 11. So I'll have 11 times 7 raised to the 1/3 power. Remember, that's as far as you can go on this one here, because you can't say 11 times 7 is 77. I see that a lot. Again, the only thing we can do is if we had the same exponent, we would have to have the same base, yada, yada, yada. All right? So don't tell me it's 77 raised to the 1/3 power. So those two are pretty straightforward. Now on this next one here, again, you're going to have to start thinking, how can I break up the 4th root of 48? Do I have some number? Because again, I see that 3 there. Do I have some number times 3 that will equal 48? And you'll say, yeah, it's 16. So we can write this now as the 4th root of 16 times the fourth root of 3. I already broke it apart from yesterday's notes, okay? So if I do that, oops, I didn't mean to put the equals here yet. Then I can take minus, oops, where did that come from? Minus the fourth root of 3. Now, I want you to think, what number times itself 4 times equals 16? Okay, so 2 times 2 is 4, times 2 is 8, times 2 is 16. So we can write that the fourth root of 16 is 2. So I have 2 times the fourth root of 3 minus 1 times the fourth root of 3. And on that one there, we could just write it as the fourth root of 3. Okay. All right, so the properties of rational exponents can also be applied to expressions involving variables. Because a variable can be positive, negative, or 0, sometimes absolute value is needed when simplifying a variable expression. So when n is odd, the nth root of x to the n is just going to be x, right? And that one should make sense because remember, we can have a negative under the radical, but we can't have a negative under the radical when it's even. So to fix that, they're saying when n is even, the nth root of x raised to the nth power is equal to the absolute value of x. All right. So on this one here, we would have to say the absolute value when it's done. All right, and you'll see here in a second. If we were just doing a regular paper and pencil test, I would say I wouldn't worry that much about it myself. But since we're taking the tests on the Big Ideas platform now, ladies and gentlemen, I really think that they're going to make you use the absolute value. All right, we'll kind of see. I'll check, and I'll probably give you extra, I'll partial credit if they do require it. All right. So on the first one here, again, you want to take that 27 and you want to be able to simplify it. So, and eventually you're going to figure some of these out, but 3 times 3 is 9, times 3 is 27. So I can write this 27 as 3 cubed. And then I have d. And again, what I want to do here is I want to get d so that it has a cube there so I can kind of get rid of it. Now remember, I can do a power raised to a power. So 3 times what would equal 12? And you would say, oh, it's 4. So I can write it as d to the 4th cubed. All right. So now remember on that, I told you, again, a cubed and a cubed root cancel each other out. So on that one there, we'll have 3. And on this one here, again, a cubed root and a cube cancel each other out. And we'll have d to the 4th. All right. Now, I don't have to put an absolute value on that one there because it's only when those two are the same. So on our next example, we're going to do the same thing here. All right. And I will do, let's see, I can split these up. So I can write this as the 4th root of x raised to the 4th power. And on the bottom, I can take y And I can write that as, let's go ahead and just write it as y to the 16th now. But what you should realize is that on this one here, on the top, I have a 4 there and I have a 4 there. Since they're both even, that one there, I would have to put the absolute value of x. On the bottom, I can again think about this. What times what? Because again, I want to do a power raised to a power equals 16. And you can tell me that's going to be, excuse me, I meant to do a y there. You would tell me that's y to the 4th raised to the 4th power. So again, this 4 here and this 4 here, okay, they're going to cancel each other out. So the top is the absolute value of x. The bottom is y raised to the 4th power. And I'm all done on those ones. Okay? Now, you only have to do that when they don't tell you that it's going to be a positive. So absolute value is not needed when variables are assumed to be positive. So example 7, write each expression in simplest form. Assume all variables are positive. Once they told us this right here, we know we're good to go. We don't have to worry about absolute value. Okay? So on this one here, let's see here. I'm going to take, and I want you to kind of think here. All right? You can write some of these down, but sometimes I find if you look at them as a fraction, you can get something better out of it. So let me show you what I mean by that. So we can write a, the third root of a to the 13th. Remember, I can write that as a to the 13 over 3. Remember that 13 over 3, the bottom one is always going to be your index right here. Okay? Now, I want you to think on that one there. What would be the first number that I would have that I could divide, well, the highest number I could have to divide that would give me an even number, okay? So if you think about that, you would tell me, well, I would say it's a to the 12 divided by 3. But then again, I have a to the 1/3, all right? That's going to be important here for us in a second. So remember, when the bases are the same, I can add the exponents. I can also take them apart. All right. For C, what do I have there? Well, B, I have a cube and a cube. So I know that one's going to just come out in front. All right. What about for C? I'm going to have 8/3. On that one there, let's see. Oh, 6 divided by 3. So I'll have C raised to the 6/3 power, and then I'll have C raised to the 2/3 power. All right. So what this should tell you is when this number here, the numerator, is less than the denominator, that has to go back under the radical. Okay? So with all of what I just told you here, just watch what I did. Well, we didn't do anything with the 2. So it's going to be here, and it's going to be under the cubed. Anything that is a whole number, so this part right here, we just found out that that is what? A to the 4th. And what do we have left underneath? Again, here's our index. That's our cubed root. So underneath the radical, on that one, we're just going to put an A. The B, again, think about this one here. The 3 and the 3, They cancel each other out. So I can put that out front. And then for the c, I have 6 divided by 3. That is going to be squared. So I can put the c squared here. And what do I have left underneath? Again, here's my index part. We already took it there. So we're going to have c squared. And that is our answer for that one. And let's do the same thing on C here. I mean B. So on B here, let's see here. What can I do? All right. I have 13 here. All right. So I have y to the 13 thirds on the bottom. Okay. I also have that radical symbol underneath. So what can I add to that 13 thirds to get a number that is a whole number? All right. So if you think about it, let's see, I can do 2/3, or think about what I just have been saying here. That would be the third root of y squared. And then remember, whatever I put on the bottom, I have to put on the top. Remember, now I can put those together. That's going to be y to the 15 thirds. And what is y to the 15 thirds? That's y to the 5th. Well, let's go ahead and write what you have there, and then we'll simplify it. So you have x squared. You have 3, the third root of y squared on the top. And on the bottom, what we just talked about, you have the cubed root of y raised to the 15th power. So like I just said right here, what does that make? What's 15 divided by 3? That's going to be y to the 5th, right? So on the bottom, you're going to have y to the 5th. You got rid of the radical. Good job. And on the top, we're going to have x squared times the cubed root of y squared. And that is that one right there. All right. Let's see. On C, now I want you to think about stuff again. Here's what I've noticed a bunch of times. A lot of people will forget that you can reduce a fraction. So I kind of said the easiest thing to do here is, what is 16 divided by 8? That's going to be 2. That is our number. Now remember, we're going to have, maybe I should do a different color off to the side here. We're going to have x to the first power. Remember, on the bottom there, we now have a x to the 2/3. So remember, when the bases are the same, and I'm looking at this part right here, what do you do to the exponents? You subtract them. Well, again, with 1, we have to find it as a fraction. So remember, 1 is 3/3. So I have 3/3 there. All right, so what is 3/3 minus 2/3? And you'll tell me it's 1/3. Now remember, if it's in exponent form, you have to leave it in exponent form, but you can move them back and forth until you get the right answer. If it's in radical form, you have to put it back in radical form. So let's see here. Now we have the y. Do you have a y on the bottom? No. So let's just say we have y raised to the 1/3 power. And remember, if something is negative on the bottom, you move it to the top. If it's negative on the top, move it to the bottom and change the sign. So we would move this up to the top, and it would be z to the fourth, and I'm all done with that one too. And finally, our last ones here. Perform each indicated operation. Again, assume all variables are positive. So they're kind of doing the same thing as they did with the ones on top. Again, I have a cubed root of x and a cubed root of x. So on that one there, again, after a while, you should be able to just say that it's 6 plus 2 times the cubed root of x. Or you could even just say, oh, right away, I know that's going to be 8 times the cubed root of x. And let's see. On B here, I have 16. I have the fourth root of 3 p to the sixth. All right. So again, I want you to think here. This one here is larger than this one here. So we would be able to break it up. Remember, our thing is when the bases are the same and I'm multiplying, I add the exponents. So if I can break that 6 up to p to the fourth times p squared, does that work? And you would say, why, yes, it does. All right. So if that's the case, then I can have 16. Again, I'll take this p to the fourth and that fourth, so those will cancel. The fourth root and the 4 exponent cancel each other out. So I'll just have a p there. And what I have left is the fourth root, not the cubed root, the fourth root of, what do I have left in underneath the radical? That 3, because that would have given me a number that I can use. And I have p squared. On the next one, I have, let's see here. What can I do there? We just talked about 48. I think we just did that one earlier. So we could write that 48 as what? 16 times 3, right? And we know that 16 is going to be 2 to the fourth. All right. So if we know that 16 is 2 to the fourth, again, there's our 4 there, there's our 4 there. So they're going to cancel each other. And I can bring out that 2 out of the radical. I already had that p there because it was on the outside, right? And then what do I have left? Well, I have 3. Oops, I didn't mean to erase that. I have 3, right? So that 3 can go stay under the radical. And I have p squared under the radical. And it's to the fourth root. Okay? So now, again, now it's just the same. Let's see. I have 16p minus 2p. So you have 16 p's. I take 2 of them away. How many do you have left? Well, I have 14p. You are right. So I'm going to say 14p. And again, I have the fourth root of 3p squared. And that's my one there. All right, so a little more involved this time, but still doable, ladies and gentlemen. You will get good at these, trust me.